Hello everyone. So today's question, we will be solving questions using the equation Q equals mc delta T. So Q stands for heat, and this is measured in joules, so J. M is mass, and this will be measured in grams. C is something called specific heat capacity. This is how much energy is required to increase or decrease the temperature of an object by 1 degree. Next, we have T. T stands for temperature, and this is measured in Kelvin. And for specific heat capacity, the units would be joule per gram Kelvin. Now to solve this question, let's see what we have. So it gives us the mass of water. So let's write down the formula first. Q equals mc delta T. It gives us the mass of water, and it gives us an initial temperature and a final temperature. So the mass of water, it is 250 grams. So mass equals 250 grams. It's starting at, so this is temperature initial, or T1, 75 degrees Celsius. Now to convert this into Kelvin, you'll be adding 273.15. So I'll write this up here. So 273.15 Kelvin is actually 0 degrees Celsius. So in this case, 75 degrees Celsius is actually 348.15 Kelvin. It gives us temperature 2, which is 20 degrees Celsius, and it states that the final temperature, 48 degrees Celsius, which is 321.15 Kelvin. We're dealing with water and with tin, because it says here tin and water. So the C of water, so I'll just write water. The specific heat capacity of water is 4.18 joules per gram Kelvin, and the specific heat capacity of tin, which you can look up, is 0.21 joules per gram. So first, let's calculate the temperature and the Q value of water. So for water, we have Q equals 250 grams. This is multiplied by the specific heat capacity of water, which is 4.18 joules per gram Kelvin. And then for the temperature, so the temperature is going to be, it says that the final temperature of the whole system is 48, and the initial temperature of just the water is 75 degrees Celsius. So what we're going to do is we're going to do 321.15 minus 348.15 Kelvin. When you plug this all in and solve, you should get negative 28,215 joules. Now, the negative value just means that it is releasing heat. And then from here, now we're going to calculate tin. And the amount of energy that is released by water is going to be the amount of energy that is absorbed by tin. So from here we have 28,215 joules equals we're trying to solve for the mass of tin. We've already looked up the specific heat capacity of tin, which is 0.21. And in terms of the temperature, the final temperature of the system is 321, and the initial temperature is 293 Kelvin. From here, we're going to continue to solve. So mass equals 28,215 divided by 0.21 times 28. And that means that the mass is going to be 4,798